Good morning, my dear students. Welcome to physics class. Today we are going to start our second chapter in physics, that is the human eye and the colorful world. Okay, the colorful world. In this chapter, we are going to discuss the first one is the human eye. That is the structure of human eye is discussing in the first session in this chapter, and some disorders, okay, and some disorders of human eye. And the next session we are going to discuss the natural phenomena, that is the light natural phenomena like dispersion, scattering, etc. Okay, today we are going to discuss the topic refraction through a glass prism. Refraction through a glass prism. Okay, in the first chapter we discussed what is refraction, and refraction through a glass slab already discussed in first chapter. Okay, here we are going to discuss the topic refraction through a glass prism. Okay, first of all, what is a glass prism? Okay, this is a glass prism. You see this? This is a glass prism. It made up of glass, and it consists of two triangular face. Okay, this is one of the triangular face, and this is second triangular face. That is, a glass prism consists of two triangular faces. Okay, this is first one and this is second one, and it consists of three rectangular faces. Okay, that is three rectangular faces that is inclined each other. Okay, or inclined rectangular faces. There are three inclined rectangular faces, that is 1, 2, 3. Okay, that is, this is a rectangular face. Clear? Okay, this is a glass prism. The angle of this glass prism, or the angle of the two inclined faces, the angle between two inclined faces is called angle of the prism. Angle of prism. Okay, angle of prism, that is the angle between two lateral faces. Okay, two lateral faces, the angle between two lateral faces is called angle of prism. Clear? Angle of prism. Okay, that is, here we are going to discuss refraction through a glass prism. That is how the refraction is take place in this glass prism is discussing in this topic. Okay, shall we go? Okay. Okay, listen here. First of all, we consider a glass prism. This is our glass prism. Okay, and I am passing a light obliquely into this glass prism of face AB. Okay, that is, here two inclined faces, that is, this is interface. Okay, this is AB is a interface between air and glass. This is a glass, therefore AB is an interface between air and glass. Okay, here a PE is our incident light. Okay, we have when a light is coming from one medium to another medium, that time this light is bending. Okay, that process is called, that phenomenon is called what? Refraction of light. Okay, that is here at this interface, this light ray is refracted. Okay, refracted. That is EF is the refractor ray. Okay, here PE. Here PE is the incident ray. Incident ray. And EF is the refracted ray. Refracted ray. Okay, and I am drawing a normal to this face. That normal is considered as N dash. Okay, here N dash is the normal to the face AB. Okay, and the angle between this incident ray and this normal is called what? Incident angle I. Okay, that is angle I is called angle of incidence. Angle of incidence. Clear? Okay, and the angle between this refractor ray and this normal is called angle of refraction R. Okay, that is angle R is the angle of refraction. Angle of refraction. Clear? Okay, here the light ray is coming from rare medium to denser medium. That means this refractor ray is towards the normal. Okay, towards the normal. And next case, this refractor ray is incident on this face, that is interface AC. Here the light ray is coming from glass to air. Okay, glass to air. That time this ray is refracted or bended away from the normal. That means here this is the normal. Okay, suppose M dash. Okay, M dash is the normal to the face AC. Okay, this time this refractor ray is away from the normal, and this ray is called emergent ray, that is FG. FG is the emergent ray. And the angle between this normal and this emergent ray is called emergent angle. Okay, that is angle E is called emergent angle. Okay, emergent angle. Here the emergent angle and incident angle are equal. Okay, that is angle I equal to what? Angle E. Okay, emergent angle equal to what? Incident angle. Clear? Okay, and one more thing. Here this emergent ray is bent at an angle in the direction of incident ray. That angle is called angle of deviation. Angle of deviation. that angle of deviation is formed here, D. Okay, that represented as capital letter D, that is angle D. Angle D is called angle of deviation, that is the emergent ray bent at an angle to the direction of incident ray. This angle is called angle of deviation. Okay, angle of deviation that represents as angle D, capital letter D. Okay, this is the refraction through a glass prism. Okay, is it clear? Okay, this is very important. This diagram is very important, and the terms related to this diagram also very important. Okay, clear? Okay, this is refraction through a glass prism. Okay, next we are going to discuss the topic dispersion of light. That is, it is a light natural phenomenon. Okay, light natural phenomenon, and in the first chapter we discussed some light phenomena like refraction and reflection, and here we are going to discuss the first phenomenon, light phenomenon, dispersion of light. Okay, dispersion of light. Before going to discuss this dispersion of light, first we want to study a term, composite light. Composite light. Okay, what is composite light? Okay, listen. Here the composite light is any light that composed of more than one color of light. More than one color of light. That type of lights are called composite light. That is, a light is forming or composing from more than one color of light. That is called composite light. For example, white light. White light. White light is an example for composite light, because this white light is composed more than one colors. That is, this white light is composed by using 7 colors. 7 colors that are Vibgeo. Vibgeo. What is Vibgeo? Vibgeo is violet, indigo, blue, green, yellow, orange, red. Okay, this white light is the combination of these 7 colors. Therefore, this white light is a composite light. Okay, white light is a composite light. And the visible light or sunlight. Sunlight also a composite light, torch light, candle light. These are examples for composite light. Okay, what is composite light? Composite light is any light that composed of more than one color of light is called composite light. Examples, white light. One of the examples is white light. This white light is composed of 7 colors, or by using 7 colors, that is Vibgeo. Violet, indigo, blue, green, yellow, orange, red. Okay, this is the constituent colors or component colors of white light. Clear? Okay, and the sunlight or visible light, torch light, candle light, these are the examples for white light. Composite light. And one more thing, the laser light. The laser light is not a composite light. Is it clear? Okay, this is composite light. Clear? Okay, next we are going to discuss dispersion of light. Here the dispersion of light or dispersion of white light is the splitting of white light into its component colors or its constituent colors when it passes through a transparent medium. Okay, when it passes through a transparent medium. What is dispersion of light? When the splitting of white light, listen, the splitting of white light into its constituent colors or component colors when it passes through a transparent medium. It is called dispersion of light. Okay, what is that? For example, the white light is splitting into its component colors or its constituent colors it is called dispersion of light. That is, this composite light or this white light is splitted into its component colors when it passes through a transparent medium. Okay, that phenomenon is called dispersion of light. Dispersion of light. Clear? Okay. Sir Isaac Newton is explained this dispersion of light through experimentally. Okay, next we are going to discuss that experiment. That is dispersion of light. Okay, dispersion of white light through a glass prism. Okay, through a glass prism is going to discuss next. Okay, for that I am considering a glass prism and a white light. The white light is passes to this glass prism. That time you see this white light is splitted into its constituent colors, that is its component colors like Vibgyos. Okay, that is violet to red. Okay, first he passes a white light into this glass prism and at this interface this white light is splitted into its component colors Vibgyo. Okay, here after this total refraction, that incident on a screen. Okay, that is violet to red. Clear? And in this case, you see here the bending of light or the deviation of light is greater in the case of violet, and in the case of red the deviation is very less. What is the reason for that? Listen, you already studied wavelength. Okay, in the lower class you studied the term wavelength. Okay, that is the distance between two adjacent crust or trough is called wavelength of a wave. Okay, here the wavelength of a white light, the range of a wavelength of white light is 400 nanometer to 700 nanometer. Okay, 400 nanometer to 700 nanometer. Here we form a color Vibgyo. Okay, this is a correct order arrangement. That is, this colors formed by dispersion is called, or the arrangement of these colors formed by dispersion is called spectrum. Okay, spectrum. The arrangement of colors formed by dispersion is called spectrum, that is visible spectrum. Okay, in this spectrum the violet has lower wavelength. Okay, violet have lower wavelength and red has greater wavelength. Due to that, here the deviation is different. Here the deviation is high or greater. In the case of violet, the deviation is greater. Why? Because the wavelength of violet is less. Okay, and in the case of red, the deviation is less. Why? Here in the case of red, the wavelength is high. Okay, that is, here the wavelength is influencing this deviation of colors of light. Clear? Okay, this is the dispersion of light. Clear? Okay, I hope you all are understand this topic, that is dispersion of light. Clear? Okay, thank you.